Hey guys, so far we have learned how arrays works, like how to declare them, initialize them and even access each element easily. But here's the question. What's really going on behind the scenes when we create an array? How does the computer actually store these elements in memory? That's exactly what we are going to uncover in today's video. The memory representation of an array. Let's start it. When we write a program, every variable we create is stored somewhere in the computer memory. That is our RAM. For suppose in a program, if we write something like this int a equal to 4, then the value of a, this 4 is stored in the RAM memory. Let me show you in the visual way. Let us suppose this is our RAM and we have many memory locations in our RAM. Like it is 1000, it is 1001, 1002, 1003. Like this, we have n number of memory locations. So when you initialize an element like this 4 is stored in a memory location. Like this 4 is stored in the address of 1002. The symbolic representation for this memory address is A. So when we refer to A, it means we are referring to the value in the memory address 1002. Cool. It is just a normal representation that I am showing to you to make you understand how a value is stored in our memory. But it's not how a value is stored in a memory. Let me tell you how it goes. Most of our computer systems allocate 4 bytes for integer. It means size of int is 4 bytes. We know that 1 byte means 8 bits. Similarly, 4 bytes, 32 bits. Cool. Here, each block in the memory is a byte. Like this, we store our integer value in 4 bytes. It means this is our RAM and we have many bytes like this here. And for example, it is 1001, 1002, 1003, 4 and 5. We should store the value of 4 in this block. It's of 4 bytes and we should store the value of 4 in this block. Cool. But this is not how it stores actually. It got stored in the binary representation of 4. So let me show you how it got stored. Binary of 4 is 0100. So here we have 4 bits. In a 1 byte representation, we will write it as 0000 and 0100. Similarly, in a 4 byte representation, we can write it as it is 1 byte. Similarly, we will be having 4 bytes and here we will be having like this 0 1 0 0 and remaining all are zeros. It is our byte 1 2 3 and 4. It is the 4 byte representation for our value 4. Now there are two ways in which we can store these bytes in the memory. Let's check them. The first way of representation is by writing byte 1 here and 2 3 4. So these 4 combinedly will represent the value 4. And second way of writing is byte 1 2 3 4 and these 4 represent the value 4. So these are the two way of representation and we will call this representation as Little Endian and this representation as Big Endian. So these both represent the same value 4, but one is top to bottom representation and another one is bottom to top representation. So this is how a value is stored inside our memory. Now whenever you try to print this value like print of percentage d and a, it means the compiler will see the variable a, and this a represents the address 1002, and simply it will come to that address 1002, and as it knows a is an integer, it will consider this complete block as the value of a, and in this complete block we have the value 4. So it sends the value to here, and this is how 4 is printed here, and this is how we will access all the values of variables from the memory. Now let's do the same for an array. Let us take an array of size 5, and let me initialize with values 10, 11, 12, 13 and 14. Here our size of the array is 5. Each value of this array is integer. That means we know that size of int is 4 bytes. In such a way, we have 5 integers. It means a total of 20 bytes is required to store this complete array in our memory location. In our array definition, I mentioned a term like contiguous memory location. It means continuous block of memory. Suppose if our memory is like this and we have many bytes in our memory, this is our RAM memory, and we required 20 bytes of continuous memory here. Remember this term, 20 bytes of continuous memory block. But in our memory, maybe these blocks are occupied here. Maybe like the blocks I am marking, maybe they got occupied, and these are free spaces, and we cannot insert one value here and some two values here and remaining three values here. No, we cannot do something like this. We need a continuous block of memory. It is not continuous because there is a gap here and here. So our array will not be stored like this. It will search for the continuous block of memory. For example, the space between 6 and 25 is free to store. So we got 20 bytes here, and in these 20 bytes we will be storing our 5 values of an array. So from 6 to 9 we store the value 10, and from 10 to 13 we store the value 11, and from 14 to 17 we store the value 12, and from 18 to 21 we store the value 13. Similarly, from 22 to 25 we store the value 14. It is how all the elements of an array stored in a continuous block of memory space. Since all elements are stored side by side one after another without any gap in between, we will call this as contiguous memory locations. Let us see how can we access an array by using this memory representation. So if you write something like this, an array of 3, here it calculates two things. The first one is base address of an array, base address, and second one is index. And our base address of an array is the address of first indexed element. It means simply our first element. Okay, so in our example our first element is 10, and the base address of this 10 is 6. So this is our base address, 6 is our base address. Cool. And our index is 3. So to calculate array of 3, simply we will do a small math here. Base address plus index into number of bytes, 4 bytes. So this 4 is bytes, and this is index, this is our base address. Cool. So our base address is 6, right? And then 6 plus 3 into 4. So how much it is? 4 3 is 12, and then 18. So we can get the third indexed element at the memory address 18. So if we find here 18 is the base address for the element 13. So from 18 to 21 it is a 4 byte, right? So in these 4 bytes the value of 13 is stored in binary format. So it is how we can access all the elements in an array by using base address and index. It is all about the memory representation of an array. If you guys like this concept, please do subscribe us. Thank you.